Okie dokie. So here's a hyperbola that we want to sketch. Now, first off, how do I know it's a hyperbola? The way that you can figure that out is if we look at their x squared and the y squared terms. What this means is that since the x squared is positive 4 and our y squared term is negative 9, we know that this thing is going to be a hyperbola. If they were the same, then we know it would actually be an ellipse. Okay, so notice here I didn't give it to you in that nice little graphing form, so just like with the ellipse and the circle problem, we're going to have to complete the square to get it in that way so we can actually graph it. So I'll start off the same way that I have been by organizing all my terms. So I like to have the x stuff first, 4x squared plus 32x, and I'll do the y's in a different color here, minus 9y squared plus 54y is equal to 53, and of course we just moved that 53 over. Since I know I'm going to have to complete the square, I'm going to factor out this 4, leaving the x squared plus 8x plus something. And then for the y's, I'm going to factor out a negative 9. Again, I want that y squared coefficient to be to be 1, exactly, positive 1. So this would mean that I'm left with y squared minus 6y plus something is equal to 53. Oops. So for the x piece, the part that I'm going to have to add in, I think, half of 8 and then squared would have to be 4 squared plus would be 16. And don't forget that times 4 on the outside. So I'm actually adding in on both sides 4 16s. So plus 4 times 16. And in purple here, let's see, I'm going to have to add in half of 6, which would be 3. Squared would be 9. So I'm adding in negative 9 nines on the left side. So I'm going to have to actually add in negative 9 times 9 there, or subtract in this case. So let's clean this up. That'll leave me with 4 times x plus 4 squared minus 9 times y minus 3 squared. That's going to equal, let's work this out. So this is going to be 53 plus 64 minus 81. So let's see. This already is going to be, let's see, 117 minus 81. Leave me with, I think that's 36. Nice. So that's 36. And I want this guy to equal 1 on the right side, so I'm going to divide everything by 36. And again, it's not always going to work out where it works out just nice and neat, because sometimes you'll get an irrational answer. That's totally fine. It just, obviously for these examples, we want to make it nice and palatable. So on the x pieces, I'm going to have x plus 4 squared over 9. And then for the y's, I'll have y minus 3 squared over 4 equals 1. And let's just find our x and y radii by rewriting it as x plus 4 over 3 squared minus y minus 3 over 2 squared equals 1. Alrighty, so what can we figure out already? Well, the easy stuff is figuring out where our center is. So if I rewrite this as x minus negative 4, and this part is y minus 3, then I know my center is at negative 4 comma 3. I also know that, well, that's my x radius, and this is my y radius. So my slopes for my asymptotes, so I'll say slopes, or asymptote slopes, it's going to be e plus or minus 2/3. And so I can kind of already get started on this. Let's see, I'm going to go over 4, so I'm going to draw it like this. Negative 4, so it's 2, well, I'll go by 2s, so this will be negative 4 right here. So let's see, at negative 4 comma 3, so that's my center right here. My slopes are going to be up to 1, 2, and then over 3. 1, 2, 3. And so that's 1. And then the other one will be up to left 3. So up to 1, 2, 3. So those are my slopes. So let's draw these in. Now this one's going to be like this. Alrighty, so hopefully we got to this step from the previous videos. And the question is, which way does it open up is the last piece. Well, we could, if you remember just from the last video, we can tell from the sign of the signs of the x squared terms and the y squared terms. Since in this case my x squared is positive right here in purple and the y squared is negative, we actually know that it opens up horizontally, which would mean this way. And the quote-unquote vertices of these pieces would also be 3 away, depending on which way it opens. So since it opens in the x direction, the distance from the center to the vertices is going to be 3. So I can go out 1, 2, 3, and that's where the vertex is going to be. 1, 2, 3. Okay. And that is how you can tell where it's going to open up. But what if you didn't remember which way it is? Because that happens like on a test or something. Like, oh, darn, does it open up in the direction with the negative x squared, or in the negative term or the positive term? Because it seems, just if you try to memorize it, it seems kind of arbitrary. Okay, so what could I do? Well, one thing you could do is you can plug in the center, in a sense. So notice you couldn't do this on an ellipse, because if you plug in the center, like the coordinates for the center, the xy coordinates, you'll get 0 plus 0 equals some not zero number. But here's what I mean. If we look at this coordinate right here, this coordinate is -4, 3. This coordinate right here, well, that'd be -4 plus the x radius, which would be 3, 3. Its y coordinate is still 3 because all we did was go left or right. In other words, it is -1, 3. This one right here is, let's see, -4, minus 3, 3, or -7, 3. Why am I pointing this out? Notice this graph exists, like on this graph, the graph has, how could I word this? Has y values with, sorry, how about this? How about the graph shares y values with the center. So notice the center is not actually part of the hyperbola. It just helps you graph it. So the graph itself, though, actually does share y values with the center. It does not, however, share x values. For example, if I go down the line here, x equals -4, the graph doesn't exist there. The graph doesn't share the x value. With the center. That on its own should tell you where it opens up. So let's actually do this for this one. Now we already know what it looks like, but just to confirm, let's take a look at this. So I'll have x plus 4 over 3 squared minus y minus 3 over 2 squared equals 1. So what I'm going to do is I'm going to plug in the coordinates one at a time. So I know my center is at -4, 3. So I'm going to plug in x equals -4. Okay, and let's just see what happens. So if I plug in x equals -4, well, that just makes that x minus 4 term, or sorry, x plus 4 term 0. And so I'm left with negative y minus 3 over 2 squared equals 1. We mentioned this in the, I think that was the last video, that this cannot happen because you're squaring something but once you take which makes it positive, and once you stick a negative sign in front of a positive number, it becomes negative. There's no way that negative number equals positive 1. This would suggest that the graph doesn't exist. So the fact that there's no solution to this implies that the graph doesn't exist. Exist when, what did we say, x equals -4. In other words, -4 is not in the domain, which would be a fancy way of saying that x equals 4 isn't in the domain. What does this mean then? Well, because the hyperbola, and we know what a hyperbola looks like now, I'm going to give a very, very rough sketch here. Let's see, so here's the centers at -4, 3, somewhere around there. Sorry about that. But because the graph doesn't exist when x equals -4, that tells you that at this point there is no graph. Right here. Doesn't work. And therefore, since the hyperbola can only open this way, or and that way in red, or the purple way, you just ruled out that it couldn't be the red way. So it has to be the purple way. So hopefully that explanation makes sense. If we couldn't figure out, or if we can just remember, hey, it's positive, so it opens up this way, or it's negative, so it opens that way.